Okay, we had left off with uh, this information last week. Okay, so on the right side over here, you might not be able to see this, but whether it's we're looking at magnesium and chlorine and iron, they're up there on the board. What important information, if you were looking at those assorted elements, what's everything that you could tell me about magnesium? And you won't be able to tell anything unless you have your table out and we're looking at it. So the first thing you'd want to do is find magnesium. Okay, it's got a +2 charge. Yes, that's correct. It might say oxidation state. That might be your vocab term, but yes, it's got a +2 charge. What else can you tell me about magnesium? Okay, that 24.3 is magnesium's what? Atomic mass. Okay, what else can you tell me about magnesium? Its symbol is Mg. Okay, and probably the most important aspect is what? True. You're missing the most important number. Number 12. So that 12 for magnesium is telling you it's what? It's atomic number. So magnesium has an atomic number of 12, which gives you the number of what? Protons. Now, it'll be a little different when we get in next chapter and a little further down when we start talking about electrons more in depth. Is this where we had left off or where we begin? This is where I thought we left off. Okay. 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 See, I was looking for that saying atomic mass. Okay. So we said magnesium has an atomic mass of 24.3. So let's say we're going to give magnesium an atomic mass of 24. What is everything that you can tell me about that? Protons, neutrons, and electrons. Are the numbers the same or are they different? So atomic number is 12, so it's got 12 protons. If it's neutral, how many electrons would it have? 12, because remember the atomic number gives you the number of protons. If it's neutral, the electrons also has to be 12. So subtracting the atomic number from the atomic mass gives you which final particle? Which one? Nope, we gave you the electrons already. The neutrons. That's right. So one of the things that we've only said once, when you are looking at any periodic table, probably about 98% of the time, yes, it is arranged in increasing atomic mass. But there are some exceptions to that. If you really want to look at it correctly, it's arranged in increasing atomic, not mass, but rather atomic number. So as you go from left to right, it's increasing by an increment of 1, which means you're adding 1 what every time? You're adding a proton as you go from left to right. That's correct. Okay. Okay. So again, the atomic number is the number of protons within the element's nucleus. So, and we've done parts of this before last week, dealing when it comes to the mass number, that will give you the number of neutrons in that element. We want to try to get through a couple more slides in this presentation. Then we're going to start working on Bohr models. We worked on them last week, very briefly, okay? And as we went through the class, if this material is something that is not clicking and you're not understanding it, if you're not asking any questions or finding extra help, you're not doing yourself any favors. All right? Okay, so we want to do this one, and then that one. I think that should do it, yes, because that will take us to the end of the section. So does anyone know the name or term that this is referring to? We dealt that with carbon. We said carbon 12, carbon 10, carbon 14. Say it again. Isotopes. So when you vary the number of neutrons, even with that of the same yeah, with the same element, well then you're just changing the number of neutrons. Okay? So on your table, you have carbon 12, all right? So the thing that is not going to change is the number of protons between carbon 10, carbon 12, and carbon 14. And last week, we correctly had identified what is changing between carbon 10, carbon 12, and carbon 14. The number of what? Not electrons. Protons has to be the same. So the only one that's left, that is neutrons. That is what we refer to as an isotope, okay? That's what we're talking about, carbon 12. That's what you see on your periodic table. But there are different forms of carbon that exist. And when we talk about varying elements, we're talking about isotopes. The protons will still be the same, but the number of neutrons will vary. and not all elements on this table would have a naturally occurring isotope. Some do, but a lot don't. Okay. Okay, does everyone have this information that would like it? Okay, so you're done writing materials down. So where you have done your examples from last week, I would say keep them in the same place. Okay, so you're gonna want to find where your slide rule is at as well. You're gonna want your table, the slide rule, and either some scratch paper where you had done some of the examples from last week. All right. So we started today talking about magnesium. So what is everything that you can tell me about magnesium? What's its atomic number? What's its atomic mass? Now, we're going to say it's 24. It's actually 24.31. Okay? Now, these are not always wrote or written like this. Okay? So you're going to want to know the atomic numbers. That is probably the most important aspect on that periodic table for each element's box. Okay. So what can you tell me about all the subatomic particles? We did that just no more than 2 minutes ago. Protons, how many? 12, because it's given by your atomic number. The charges add up to 0, so it's got 12 positive charges. Number of electrons is also 12, which have negative charges, so that adds up to 0 and also has 12 neutrons. Okay, so we're going to start doing what we call Bohr models. We just did one as an example last week. I can't remember what it was that we did. I want to say it was beryllium, maybe. Okay. Might. Oh, we did nitrogen. Okay. All right. So now, we're going to do what's called a Bohr model. We just never said what it was last week. We did nitrogen, but now we're going to do the Bohr model for magnesium. So, inside that nucleus of magnesium, we know we've got 12 protons because this is given by the atomic number. Okay, we know there's 12 neutrons because you subtract them two numbers. We get 12. Now is where we're going to start applying this slide rule. Okay? So, just like elementary students out on the playground, you climb to the top of a slide and you go down. And you do this in a specific order. Okay? And as these numbers get bigger, this is going to help you more and more. And you're going to get better at it the more you use it. Okay? So, what this means, the very first one, these big numbers tell you which energy level you're in, because what's true about the electron cloud? What did we say last week? It's the most likely place where what is found in various energy levels. And that's what this slide rule is trying to help you with. Okay, the only thing that's missing on here that you might have is what would you possibly see after any S block? What number? 2. Okay, so where is the S block on the periodic table? Columns 1 and 2. That is the S block. Okay? Where is the P block? Okay? Now, one good rule of thumb, okay? You see above boron to neon, it says 13, 14, 15. Just a good rule of thumb is take those ones off of there. Above boron where it says 13, scribble out that little 1. So you change it from 13 to 3. Above carbon, scribble out the 1 where it says 14 and change that to 4. And right on down the line. Because, why did we mention a stop sign last week? Because there's 8 sides to it. And what we want to associate this with is an octet or 8. And that's why we had made that reference to this on page 521. It does a good job of showing you the S block over here and the P block over here. That is why we don't want you to go from 1 to 18 across in that periodic table. We want you to do 1 through 8. Okay? All right. So, first energy level, okay? In the S block, there are 2 of them. Okay? We climbed the top of the next slide. Okay? What do you suppose that big number 2 is telling you? We need to make another line because we're going from the first energy level to the which one? To the second. Okay? Now, how many total electrons do we need to get on the outside here? 12, because we've got 12 protons in the nucleus. Who is lost right now at this point? Left outside. Are we on the bus so far? Left middle. Middle. Right middle. Right outside. Okay? So, now, 2, here's our second energy level. In the S block, we would put how many? 2. Okay? One of the things you can think about, it's kind of like a board game. And when we rolled the dice, we rolled a 12. So it's kind of like when you're going around Monopoly, you roll a 6, you go dink, 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 dink. I think that was 6. So what you're doing is an orderly manner going all the way over here until we reach the number 12, which is down here. Okay? So we keep right on going. So 2s, all right? Now, we go to the top of this slide. Are we going to a new energy level? What does that tell you? Is that a tape ball? Okay. Are we going to a new energy level? No. Okay. So how many can the P block hold? 6. So we're going to put all 6 of them in there. So how many total electrons do we have so far? 10. How many more do we need? We need 2 more. So as we keep going down this slide, okay, what is this telling you? We need a new energy level. Because we got a big number 3 here. What block is magnesium in? The energy level, yes, but which block? The letters are blocks, okay? So what column is magnesium in the S block? 2. So now, what happens when you add all those numbers together? You get 12, okay? So, looking at this table, what period is magnesium in? And it tells you what the period means right here. Okay? Here's our periods. We're in the 3rd period. Okay? So that's another way this periodic table will help you with putting the electrons in the appropriate energy levels and what number. Okay? So, notice what do we see happening going from magnesium to chlorine to iron here? These elements about the same size, or are they getting bigger? Well, this has an atomic mass of 12. What does chlorine, or excuse me, atomic number of 12, what does chlorine have? 17. What does iron have? 26. So they're getting to be a little bit bigger, okay, as we go. Okay, so what this slide rule does is it tells you which energy level you need to be in, and then which block as well. Remember, the big numbers are energy levels. The letters are blocks. And then it just goes to the, what do I want to say, the repeating pattern of which column that is in when it comes to that element. Okay, so one of the things I want you to think about here as before we do magnesium, or excuse me, chlorine. What period is chlorine in? It's in the third period. Now, what column, now the S and P together, which column is chlorine in? Now, don't go by 17, because remember we said take those ones and scribble them out. So it's in the 7th column. Now, we can make some predictions with that. Okay. So we're going to do chlorine now. So what can you tell me? Everything there is about chlorine. What's its symbol? Well, Cl. Okay. How many protons does chlorine have? How many neutrons does chlorine have? If the atomic mass is 35. 16? 16 and 17 would give you a little short. 18. Okay? So if we're dealing with chlorine, 17, 35, 17 comes from this. How do we get 18? 17 from 35 gives you 18. Okay. Now, we're going to utilize these numbers again, but remember, why do we call it the periodic table? Because these, it's just a repeating pattern over and over and over again. So we need black, purple, and red. Okay. So now, again, it's kind of like a game board. We rolled a total of 17. Okay? So we use our slide rule. Remember, we said it's in the third period, and it's in the 7th column. That will become more important here in about a couple minutes. Okay, following our slide rule, what is this telling you? The first energy level, and how many can the S block hold? 2. So we're going to put both of them in there. Okay, go to the top of the next slide. Slide down. What is this telling you? We need to go to the second energy level, and how many are in the S block? And we're going to put both of them in there. Okay. Are we changing energy levels by going to the top of the next slide? No, because it's still in the second energy level yet, but we're in a different block. How many can the P block hold? 6. We're going to put all 6 of them in there. Okay, what is, as we go down this slide, what is this telling you? We're going to the third energy level, and the 3S can hold how many? Can hold 2. Okay, now when we go over to the P block, just the P block only, what column is chlorine in the P block? It's in the 5th, okay? So as we go to the top of this slide and go down, what's this telling you? Are we in a different energy level? No. We're in a different block, but the same what? Same energy level. And you correctly told me in the P block, chlorine is in which column? 5, fifth, 5, whichever. Okay, so add all of these numbers together, and what do you get? 17. How many are we supposed to get? 17. Okay, you had told me that chlorine was in which period? Third. If it's in the third period, how many energy levels is that? 3. You correctly told me with the S and P block together that chlorine was in which column? Now, if it was just the P block, it's 5, but if it's the S and P block together, 7. So, that's where that 7 comes from. Okay? Is anybody lost right now? Because if you don't say anything, we got to believe that you understand this, and we keep going. Left outside, we on the bus. Left middle. Middle. Right middle. Right outside. Right outside. Okay. So, what can you tell me about FE now? This one's going to be a little more tricky because with FE, we've got 20, is it 6? Okay. Actually, it's 55.85, so we'll round that up to 56. Okay? So, inside this nucleus of iron, how many protons are there? Okay? How many neutrons are there? Okay? Now, as we proceed forward, okay, how many total electrons should this have to add up to 0? We've got 26 positive charges. Is it going to be how many electrons or negative charges? 26. Okay, so this pattern continually repeats itself. Okay, first energy level, S block, can hold 2. Okay? Second energy level, S block, can hold how many? 2. And we keep going to the top of the next slide. Same energy level, different block, 2p6. Okay? As we keep going down the slide, what do we see? What's this telling you? Third energy level, which block? Okay, and how many? Okay. Then we go to the top of the next slide. What's this telling you? We're still in the third energy level. New block. So 6. So we're up to 18 now. This is where it gets to be a little tricky. Okay? Because what this slide rule is telling you, that as we go down, what does that tell you you have to do? What does the 4 tell you? What about 4? We need to make a new energy level. Okay? So we go ahead and do that. Okay? And how many are in the S block? 2. This is where it gets to be really confusing. And that's why you have this slide rule. Okay? Because for some reason, it's just the way nature works, this energy level, even though it's all the way further out in the 4th level, fills up before this energy level. So notice that 4s is before 3d. Okay? That's an important concept to understand, and that's why it is so important to understand this slide rule. Because eventually, you're going to be doing elements like mercury. What's that atomic number? $80. Okay? So we've only done examples of 12, 17, and 26. Eventually, we're going to be making our way all the way up to 80. Okay? And if you understand how to use this, it's going to make things a lot easier for you. And again, if you don't understand this, please come in. We're available before school, after school, SRP, whatever it is to take more time to explain this to you. Okay, now, in the D block, what's true about the majority of elements in the D block? They're called what type of metals? Transition metals, because they can have this charge or this one. It means they alternate. That's what it means to be in transition. Okay? So, what column in the D block only? What column is iron in the D block? Okay? Now, what we don't want you to do is put that 6 out here, because that would be incorrect, because the slide rule is telling you that. How do we know that that 6 belongs here instead of here? What's true about this? Remember, this is one slide. It tells you that that 4s fills up. Then you go to the top of this slide, and what is that telling you? We're going back down to the third energy level. And which column of the D block did you tell me? 6. Okay? Now, we'll go ahead and put that in this color so I don't fumble. Okay? And add all those numbers together. What do you get? 26. Okay? So, when you're dealing with these or performing them, this slide rule tell you where you need to be at any given time. Okay? Now, these transition elements are a little different as opposed to making predictions on here. If it's an S or a P block, you can always use this. These D block elements get to be a little more tricky. This is the first time that you'd seen something like this. Is anybody lost? Left, left, middle, right, right. Okay? So what we want to do is let's start with configurations. I was thinking we were going to get to some examples in this book, but it's not quite going to look like we're going to make it. So let's go ahead and look at magnesium. Okay? So magnesium has an atomic number of 12. Okay, so, and what we mean by configuration is it's just a linear depiction of what the Bohr model was. Okay? So, for magnesium, we just follow what the slide rule is telling us. Okay? Here's magnesium's electron configuration. 1s2. First energy level, S block, 2 electrons. Following your slide rule, 2s what? 2s 2. 2p what? Then finally, keep on going, we stop at 3s what? Okay? So if you add all these exponents together, what do we get? 2, 2, 6, and 2. This is just a linear depiction or linear representation of what that Bohr model was. 1s2, 2s2, 2p6, 3s2. So again, all you're doing is showing these electrons in a linear form. It's called an electron configuration. Okay? Left outside, are we good? Left middle, are we good? Middle, right middle, right outside. I guess for a little bit of foreshadowing what's going to be coming in the future, the reason that this material is so important in understanding what column an element falls in, look at page 522 quickly. Look at figure 12 on page 522. What does it show you in that figure? It says hydrogen, lithium, sodium, potassium. All those elements are in which column? The first column, okay? So what that means is these all have a specific electron. It's called a valence electron. We're going to get into that probably later on this week. Now, since it's in the first column, it has one valence electron. That's why you see that dot there. Magnesium, on the other hand, is in the second column, right? So it's got two valence electrons. This will become more and more relevant. That's why it's so important to know and understand which column these elements are in, because the column tells you the valence number. Okay? You remember when we did chlorine, okay? So if we change this to chlorine, just like what it shows you in figure 13, that blue box, how many dots are around chlorine? 7. Okay? What we see, remember we said chlorine was in the 7th column, right? Well, that's from these two numbers added together. Or just saying column 1, column 2, column 3, 4, 5, 6, and 7. There chlorine is in the 7th column. That's why there's 7 dots there. That's why these two numbers added together add up to 7, because it's in the 7th column. Okay. We will continue with this information tomorrow. So again, if you're struggling with this, not asking for help is probably not a good idea. Pick up with this tomorrow.